MacMaths, let's do some maths today. Okay, so what I thought I'd do is I'd just do some questions with you, just spend 5 minutes and do some questions from this exercise 10A. We might need to use the cast wheel. I've drawn just sine and cos there that we can use as well if we need to. And I've picked what I think is the most sort of difficult looking question from part 3, questions 3, 4, 5 and 6 in the textbook. So I've just got the textbook, the Pearson textbook in front of me, and I've just picked one out of each of those that I'm going to go through with you now. Okay, just to make sure that you sort of understand all of these, because some of them, if you look at them, I mean, look at that there, I mean, it looks a nightmare, doesn't it? So 5D, sine of minus, and in brackets minus 180 plus theta, close brackets again, so looks quite tricky. So I'm going to go through those ones with you now. Okay, there's the cast wheel. Just remember what I said on the last lesson, that I only think of things in terms of acute angles. Okay, so every angle that I see, if it's not acute, I turn it into an acute angle, because to me, in my head, angles only exist between 0 and 90 degrees. Okay, Poppy, give me an angle that's not acute.
140 degrees.
140 degrees. So 140 degrees might seem like 140 degrees to you, but to me, when I think of 140 degrees in my head, okay, I'll just draw it in there, somewhere there, 140 degrees, there it is. Okay, to me, that is 40 degrees back from 180. You can see here I've done the cast wheel, it works both ways. Going anti-clockwise, 90, 180, 270, 360, or we can go negative. I did that in blue as well because we might need that. Okay, so there's 140 degrees that Poppy's just shouted. So to me, that is the same angle as 40 degrees. Okay, it's the same angle as 40 degrees. If I put the sine of 40 degrees into my calculator, or the sine of 140 degrees into my calculator, it will give me the same thing, the same value. Same if I put the sine of, if I go back 320 degrees, there you go, that's 40 degrees into that one, into that quadrant from the x-axis. If I put in the sine of 320, it will give me the same value as this, although it will give me the negative, a minus in front of it. And likewise, 220, okay, it's the same angle, it's 40 degrees into this quadrant. So those four values of 40, 140, 220 and 320 are all the same angle. They're all the acute angle of 40 degrees. And whether you put sine, cos or tan into your calculator with any of those, it will give you the same number. So the tan of 40 will be the same as the tan of 140, will be the same as the tan of 220, will be the same as the tan of 320. The only difference is the two values for the tan of these two numbers will be positive, and the two values for the tan of these two numbers will be negative on your calculator, but the actual modular value will be the same. Okay, same way the cos of those four angles, all the same value, number, digits. Okay, that one and that one will be positive. The cos of 40 and the cos of 320 will be identical if you put them on your calculator, and the cos of 140 and 220 will be the same as those two, but they'll have a minus in front of it. Okay, so there we go. And that's the cast wheel. Now let's use it to do these four questions, one from each. Okay, so looking at question 3, see it says, and it says there, write without using a calculator the values of the sine of 540 degrees. Okay, so without using a calculator, so this must be one of the limits, because you don't need a calculator to work it out, so I'm assuming. So if we go 540 degrees, we go 360 there, okay, to there, plus another 180, okay, would give us 540. So 540 degrees, is going round there once, and then round to 180. So there's 540 degrees. So it's the same as 180. Okay. Now, because this is one of the limits, I don't use the cast wheel for the limits. I go to the sine curve, and the sine of 180, which is there, you can see, a sine of 180 degrees is zero. So that one is just 0. Okay? Yeah, you can see that? That's what it is. Simple as that. Okay, so that's where I do use the graph. So if I came around here and carried on going to 540, I'd come back to 0. Okay? Had it been the sine of 450 degrees, if it had been that, I would have gone round 360 plus another 90, 450 is there. Okay? 90 degrees, same as 90 degrees, you could see that would have been 1. Okay? So that one is just 0. Okay? Now I am going to use the cast wheel, this next one. I'll just rub those values out so I don't confuse you. Okay? And let's put my, I don't like this not being tidy for you. I'm a tidy person, as you well know. Okay? The cos of minus 50 degrees. Okay? So positive that way, negative this way. Minus 50 degrees, draw it in. Minus 50 degrees is there. And of course we're turning into that quadrant by 50 degrees to get to minus 50. Okay? Into there 50 degrees is the same as into that one 50 degrees. Same as into that one 50 degrees, same as into that one 50 degrees if we wanted it. Okay? The same as that angle there. And that there, the cos of minus 50, okay, is in the cos region. Okay? And in that region there, between 270 and 360, or between 0 and minus 90, doesn't matter which way you're going round, cos is always positive. That's what the C says in that region. So that is the same as the cos of 50 degrees. And that question 4, it does say express the following in terms of trigonometric ratios of acute angles. So that one is cos 50, okay? That's an acute angle, okay, and between 0 and 90 degrees. So the cos of minus 50 is the cos of 50. And if you put that into your calculator, cos of, brackets minus 50, press equals, and put in the cos of 50, press equals, you'll get the same number. Okay? On question 5, it's saying the same thing, given that theta is an acute angle. So this baked bean is an acute angle. Express in terms of sine theta. So we want an answer in terms of sine theta for all of this nonsense here. Okay? So let's have a look at what this is. This is minus 180 plus theta. Okay? So let's have a look at this as an angle first of all. Minus 180 plus theta. Okay? Minus 180 is going back minus 180 degrees to here. That's minus 180. And then if we add theta, okay, it's going theta into this here, into this region here. That's what it is. That is that bit there. Now we want minus that, so we want minus that is going to go the other way than what we've just gone. Okay, so for this one we went minus 180 plus theta. Okay, so we ended up here. Oops, I put it all, I don't know, this one here. That's where we ended up. And we want the negative of that, so we want to go around. This angle here is what we've gone. We've gone effectively that angle, haven't we now? Because we've gone the minus 180 and turned back. So we've turned from there to there. And we want the minus of that, so we want to go in the opposite direction. So in other words, it's that, isn't it? That is the inverse, the minus, the other way to what we did to this instruction here. Okay? So that's the angle we want. And that angle, of course, from there to there is the same as that angle there, which we know is theta. Whoops, the baked bean. Okay? So it's the same as sine theta, and it's in the region where sine is positive. So that can be just written as sine theta. Simple. Okay? And then the last one, I did do a tan. Okay, tan of 540 minus theta. Okay, so if I get rid of all of that, again, all that nonsense. Oops, that's a squeaky noise. There we go. And if, again, there we go, put that there. And, oh, where's our way? And, yeah, got everything here. Where are we? Tan of 540 minus theta. So going round here, 360 there, and 540. Keep going, and this is 540 degrees. We got to there before, didn't we? Okay, so we've gone round once and round again to there, and then minus theta, so we're coming back theta degrees. So it's there, it's that angle there, okay? So 540 minus theta, okay, is the same as 180 minus theta. It's there, that's where it is, okay? And that, okay, is the same as this angle here, okay? That's same as this acute angle here, okay? So that's the same as tan theta, okay? Because it's that angle. Remember, every angle is an acute angle, yeah? All of these are that angle there, okay? Into that. So it's the tan of theta, but it's in this region, and in this region, sine is positive, but tan isn't. Tan is only positive in this region here. So this is minus the tan of theta, okay? It's whatever tan theta is, okay? It's going to be negative, so negative to positive tan theta, okay? And that's the lesson over, okay? So I hope you had a go at all of those, okay? They're all very similar to the examples that I've done. Use your cast wheel. For all of question 3, okay, all of these ones, 810, 360, you know, they all equate to, you know, either this point, this point, this point, this point. So use your graph, you know, for those, use your graphs for those ones, okay? And we'll do exact values tomorrow. I hope that helps, and I hope you're able to sort of go through these now, just following your finger around, find out which quadrant it's in, and deciding whether it's positive or negative, okay? It's good practice for you. Thank you. Over and out.